Okay, now that we've established a background for our passive pressure and a little bit of a disclaimer, using the slope geometry, we can begin to calculate our passive pressure using the following equation, where H is the foundation embedment depth, gamma is the soil density, and Kp is the passive pressure coefficient. Per usual, we'll remove the top 30 centimeters of soil to be conservative. So this will go down to 0.7 meters. And this accounts for disturbances during construction, and we don't want to assume that this top 30 centimeters is actually consolidated, just in case that it was, actually ended up being excavation spoils that were put back over the foundation or something like that. The area was regraded, who knows. And also, before we move on, it's important to, and just use this equation, it's important to use some engineering judgment here. So the passive pressure is relying on a soil wedge. Shouldn't that be reduced as a soil slopes away from a foundation? And remember, we looked at these two different situations from above, the screenshot from the Caltrans manual, and then what is actually happening with the slope, the beta value sloping away from the foundation. So we're going to look at how we'll reduce our passive pressure coefficient. And I'll run through through my thought process. And first, I looked at reducing the passive pressure coefficient. We'll look at reducing our passive pressure, and I first looked at reducing the passive pressure coefficient. First, we can use the full equation to calculate passive pressure coefficient. If you remember from the Bridges Prosperity Manual or the P active calculation, this is simplified to calculate for flat surfaces, but you can try calculating Kp on your own and play with the beta value and see how this changes the value of Kp, or the active pressure coefficient. You can change this from -5, -10, or -30, and you can see how drastically does Kp reduce. Now, for a -10 degree slope, this reduces from 3 using a 5 degree slope. So we'll say all the way down to about 2.77. And if we consider a 1 meter deep foundation embedded, 1 meter, we can get a passive pressure of about 12 kilonewtons per meter of wall. That's pretty good. And then option 2, we can use charts from the prescriptive code document, like the NAVFAC in Chapter 7, who've actually empirically studied the change of passive pressure with different slopes. After reading this study and comparing, which I'll link below, comparing empirical results to those calculated by the Rankine coefficient, as we did in option 1, we see that's really not a good match for calculating passive pressure of sloping backfill, just using the Rankine equation. So you can see, the active wedge that is used in the NAVFAC here, and you can see that -20 degree slope is what's used for example, and how that failure wedge is significantly reduced. So figure 7.2-64 of the NAVFAC Chapter 7, we can just read the Kp value from a chart for granular soils. And then using the same H and soil density, we can calculate passive pressure. So here we have our chart, which I'll also link below. And for -10 degrees and an internal angle of friction of 30 degrees, we get that Kp is equal to 2.2, and our corresponding passive pressure is 9.5 kilonewtons.